Objective 4. Determine whether a linear relation exists between two variables. How do we know the correlation between two variables is strong enough to conclude that a linear relation exists between them? Although rigorous tests can answer this question, for now we will use a simple comparison test. Testing for a linear relation. Step 1. We're going to determine the absolute value of the correlation coefficient. Step 2. You want to find the critical value in Table 2 for all the given sample sizes. So if you take a look here, here's the Table 2. These are the critical values, CV for correlation coefficient. If you look at the first column, this is n, meaning n is equal to 3, so the sample size are 3, 4, 5, and it continues over here in the third column from 10 to 16, 17 to 23, and 24 to 30. And then there's a critical value number that's associated with each sample size. So you want to make sure that you're using this table to use that comparison. Now step 3, if the absolute value of the correlation coefficient is greater than the critical value, we say that a linear relation exists between the two variables. Otherwise, no relation exists. Now another way to think about the procedure is to consider the figure below. If the correlation coefficient is positive and greater than the critical value, then the variables are positively associated. If the correlation coefficient is negative and less than the opposite of the critical value, then the variables are negatively associated. So, for example, does a linear relation exist? So we have been analyzing the association between club head speed and distance the ball travels. A scatter diagram suggests a positive association between the variables. The linear correlation coefficient of 0.939 also suggests a positive association between the variables. We're going to use these results to determine whether a linear relation exists between club head speed and distance. So the first step that we want to do is, step 1 is that the linear correlation coefficient between club head speed and distance is 0.939. And that's what's given in the problem here. So we know it's 0.939. So we need to take the absolute value. So when we take the absolute value of 0.939, then we get the following, 0.939. Now, in step number 2, we need to look at the sample size. Well, if you recall, the sample size of our problem was 8. So when n was equal to 8. So that means we're going to go down in the chart. We're going to come down here at 9 and n, and you're going to see where we have the value of 8. Now, if you look at the next column, the critical value for 8 is 0.707. So we can see here that the critical value is going to be 0.707. So now we're going to compare. So because the absolute value of 0.939 is equal to 0.939, we're going to see that the value of 0.939 is actually greater than the critical value. And if it's greater than, then we conclude that a positive association or positive linear relation exists between club head speed and distance.